evaluation. And what I want to do is in Excel walk you guys through some of the methodologies, mechanics, some of the formatting, okay? It is a very particular way that this type of analysis is done. It's structured in a certain way. If you were ever in a role where you had to put some type of analysis like this together, there are some norms and standards that would exist. And I want you to make sure that you have kind of that foundation, okay? So we're going to do a couple of problems, and they're going to start out, kind of simple, covering some of the mechanics that we talked about, and then they get even more and more complex. And probably the last 10 minutes of class, I'm going to show you guys an analysis that I actually created when I was doing this type of work in my my business roles. Okay, so the back, I have a project, and it has a $20,000 initial cost. Okay, and that initial cost essentially represents the investment. Okay, I'm going to record my screen while I'm going here. Then that project is going to generate $5,800 of cash inflows, and that's going to be per year. We estimate that that's not 58,000, 5,800, and that's going to occur for 6 years. Okay? And then we have a 15% discount rate. Okay? And that's going to be the rate that we use to bring the cash flows to the present value. Okay. Now is the part where I'm going to show you guys how to start setting these up. And again, we're going to start simple, and then over time, these problems are going to get more complex. Okay? If that's a reflection of the discussion that we're having, I appreciate that. Okay. So typically what we want to do is identify the years. Because, as I mentioned yesterday, there's a timeline that occurs here. So, because this project has a 6-year, we're told that the cash flows are going to occur for 6 years, we're going to have 6 years. But in doing a project evaluation, we always have a year 0, and that represents today. And that's typically the year that the investment occurs. Okay? Now, I have typed that in. It's text. That's cool. But I also want some numerical values, because when I do the formula development, it's going to be better. Okay? So I'm going to type in those years as actually numerical values. 0 to 6, just like so. Okay, so now I have the timeline, and I want to build in some of the data. So I'm told that the initial cost of the project is $1,000. So I'm going to put that in, and I'm actually going to enter it as a negative value, because it is really a cash outflow based on what I'm told about this project. So there's a couple of things that I do. I take the project cost, I enter it in year 0, because that's my initial investment, and then because I'm spending on that project, I include it as a negative value, and then I include it in year 0. If you're not told the timing of those initial costs or investments, assume they're happening in year 0. Then I have the cash flows. And again, if you're not told any information, it is typically going to happen that the cash flows begin happening in year 1. So $5,800 in year 1. So the idea is I'm going to build a lemonade stand, and I'm going to sell lemonade. Okay, it takes me a year to build my lemonade stand. I get it up and running, and then starting in the first year, I can sell lemonade. Me $20 to construct labor, materials, and then beginning in the first year of operations, I'm going to generate the cash flows of $5,800. Okay, so the idea is I can't really sell any lemonade until my lemonade stand is up and running. Okay. Then it tells me that this is the cash inflow per year. So it's an equivalent amount. So what I do is I just put an equal sign, I lock to that cell, and then I copy that across all the way to year 6. So that I have the same cash flows for years 1 through 6.
Can you zoom in?
Yes, I can. Thank you. I always forget I can see it better than you guys can. Okay. Another note here. Do not shortcut this. So if you guys remember from our present value work and time value money, that $5,800 is technically an annuity. It's happening. It's the same amount. It's for 6 years. There's a different way that you could do this using an annuity formula, but I don't want you to do that because 9 times out of 10, it's not going to be the same amount every year in reality. My lemonade stand, the reality of me, generating $5,800 every year for the next 6 years, that reality is not low, or it's not high. I don't know. Whatever. The likelihood is not high. So we're just doing this for demonstration. So this structure that I'm creating, you want to follow that. So then what I do is I create the net cash flow. I'm going to net those two numbers together. Net means sum. And I just go through and I do a summation of the outflow and the inflow for all those years. Okay? Now again, in this problem, this is not complex. Trust me, they're going to get more complex. So you want something that starts to look like this. And if you guys see something that says CF, CF is an abbreviation for cash flow, okay? Just because fingers get tired after typing the same thing over and over. All right, now what I want to do is I want to calculate the present value of the net cash flow. So what I'm going to do is use the present value formula function, and I need a rate. Okay, well the simplest thing to do is use that rate right up there, the 15%. Oops. Whoa, my formula is being quirky. Okay, so for the rate, I'm going to use the 15%. For the number of periods, I'm going to go up to the 0 that I entered as a value, because that cash flow, the number of years that the number of periods that I'm going to discount it is 0, because it's already in today's dollars. But I like to be consistent. I like to be methodical. So I'm building my formula. This $20,000 is not a payment. It does not reoccur. It is one time. So these present values we're going to be doing for single sums, which means you enter the $20,000 as a future value. Okay. No, and I did that wrong. It's not a payment because it only happens once. That 20,000 only occurs once. And you want to link to the net cash flow. Okay, if it's a payment, that means it'll happen over and over and over again. It doesn't happen over and again, it only happens once. So now we hit enter. Okay, so a couple of things here. That number, 20,000, in the present value is showing up as a positive value because of the way that Excel works. I actually don't want it to do that. So I am going to put a negative sign in front of the formula, right in front of the PV. The second thing that I'm going to do is I need to modify my formula just a little bit because that 15% is only in one cell. And when I drag my formula across, I want to lock in that cell reference. So there's a very simple Excel technique to do this. You put a $sign in front of the column and the row. Those of you that are working on PCs, you can actually hit F4 and it'll do that automatically for you. So I make a couple little modifications to my formula. It's in front of the cell reference. So the cell reference where that 15% is C6. It's right in front of the C and right in front of the 6. And basically that $sign, that's an Excel tip trick. And what it does is it says don't move the C and don't move the 6. Okay? Okay, so I like to do the year 0 value because I know if my function is correct, because the present value of something in today's dollars is the value itself. It's not discounted. So I know that I should be getting the same $20,000 value. And I also want that value to be negative because that 20,000, the totality of it, the money's taken out of my pocket to pay for the materials for my lemonade stand. Okay, now what I can do is copy that equation to the other years. And visually, I can look at this, and it should show a couple of things. First of all, they should all be positive values because the net cash flow is positive. Secondly, they should get increasingly smaller as we go from year 1 to year 6. Because that money that comes to me in year 6 is worth a lot less than the money that comes to me in year 1. So I can at least do a common sense check to make sure that my function is set up correctly. Okay. Now what I have is the present value of the net cash flow of the individual years. My next step is to do a couple things. One is I want to calculate the net present value. That's one of our investment criteria. So the net present value, what I do is I sum the cash flows, but I sum the present value of the cash flows. So there's no fancy formula equals sum. And I sum from year 0 to the very last year. And I get 1950. That is my net present value. Yep. Equals sum. And I go from the value in year 0 all the way to the value in year 6. Now, for some of you that have played around a little bit in Excel, there's actually a formula equals NPV. It works. It has a quirk to it, though. So it doesn't work awesome. I don't like the way it works. I personally don't use it. I don't need to use it because I can do what I just did. But if you want to use it, what you do is you use that rate, and then you have to use the net cash flows. Oops. And you have to start with year 1. Hold on. Hold on. You got to do it right, otherwise it messes up. Okay. And then what you have to do is outside of that function add the present value of the net cash flow from year 0. What the NPV formula does is it assumes that all cash flows happen in year 1. What I'm going to do is I'm going to post this and you guys can see the formula. This is my preferred approach to use the sum. For those of you that are curious how the NPV function works, look at it and then we'll go through it again. Okay, so that tells us the NPV of this project is $1950. So is this a project that we should do based on what we talked about? Yes, Diana, why? It's greater than 0. So the rule is if NPV is greater than or equal to 0, yes, and it is.
I have a question.
Yeah.
Why is 0's PV of net cash flows negative and the rest aren't?
Because this money we spent. The others are in, so the 20,000 is an outflow. The 5,800 is an inflow. So literally what you guys are thinking about when you do this type of analysis is it's almost like your checkbook. How many checks did I write? How many checks did I deposit? And it's all determined based on the amount of the net cash flow. So Diana, if we sold, so we're building a lemonade stand. Let's say we had an old cart or an old truck and we were going to sell it to fund, and we could sell that truck for $25,000. Guess what? The net cash flow would be positive. Right? So it's all determined based on we describe it as the economic reality of the project. But what it is, it's really how many checks are you writing? How many checks are you depositing? And does that make the net positive or negative? Okay, so NPV is one of the evaluations that we do to look at the investment. The other is the internal rate of return. We talked about that. Now, the internal rate of return, it actually uses the net cash flows. So NPV uses the present value. IRR uses the net, or what we call the undiscounted cash flow. And it's super simple. Equals IRR, parentheses, and you go from year 0 again to the final year, will return a percentage, 19%. Now, how do we know if that 19% is a good number or not? It's more than the discount rate. So, if IRR is greater than discount rate, yes. And it is. And generally, if your NPV is positive, that internal rate of return is also going to be good. I mean, there's some weird things that can go on 1% of the time, but generally, if the NPV is positive, the IRR will be as well. And then the third metric that we use is payback. So payback also uses the net cash flows. But we look at them in a little different way. So here's what I do to get payback. I take the net cash flows. I copy them. And then there is a function over here. I do paste special. And I check values, and I check transpose. Have you guys ever used this function before? Paste special, over there. Over there. Paste special. Or you can go under edit, pick paste special, and then select values and transpose simultaneously. And then hit OK. And all it does is when you've got a set of numbers that's horizontal, it pastes them vertically. If you have a set of numbers that's vertical, it pastes them horizontally. That is the glorious thing about transpose. When you've built 10,000 spreadsheets, you learn to type fast. Okay, so what I have here is the net cash flow. That's what I pasted in there. Now what I'm going to do is I'm going to calculate the cumulative net cash flow. Do you guys understand what the concept of cumulative is? What's cumulative? It's the running subtotal. So the first year, the cumulative cash flow is negative 20,000. The next year, it's the negative 20,000 plus this year, 5,800. Okay, so if you do this, 0, 1, 2, 3, 4, 5, 6. And then I keep that formula going. So I take the cumulative amount plus this year. Okay, beautiful. So I have that number. And what I've done is I've figured out that somewhere between year 3 and 4, I'm going to break even on this thing, right? That's what payback represents. So payback essentially is in what year do I recoup my investment? So the first year, I generate $5,800 of my investment. The second year, I have another $5,800. The two of them together are $11,600. So I'm still in the hole $800. And then at the end of the third year, I'm still in the hole $2,600. By year 4, I have essentially made my money back. What I don't know, though, is in what month in year 4. So I can do this a little bit simpler. Because the cash flow is consistent, I can actually take the 20,000 and I can divide it by the 5,800 because it's an even stream, and it basically tells me that I need 3.5 months, 3.5 months to break even, or to recoup my investment. So the way I would measure this payback is I would look at what my organization's policy is. If we have a 3-year payback rule, all of our projects need to pay back in 3 years. This project doesn't quite cut it because it's 3.4. If it's 4 years, I'm golden, right? And that's a very qualitative assessment that the organization is making. Okay, so this problem is a really good example of how to do the 3 different investment criteria analysis. Okay, what's going to happen generally with these problems as we get increasingly more complex is you're not going to be given these 2 numbers. We may have to figure them out. Okay. So let's do a second one, just to get it set up correctly. Okay. I'm going to give you guys the data, and then I'm going to let you guys set it up. Okay, so we are going to spend $40,000 for a new truck. We think this can increase our revenue by $18,000 per year. Okay. The life of the truck is 4 years. And we have a discount rate of 16%. Okay, so using what we did in example 1, I want you guys to take 2 minutes and set this up. As a small hint, you can actually copy what we did in example 1 and just replace the numbers. Okay. You guys got it calculated? Okay, let's talk about what you guys have come up with. What's the NPV? $10,367. And what is the IRR? 28. And bring it out to 2 decimal places. Because sometimes that will matter. And then what's roughly the payback? 2.2. Great. My little.
Did you go over how to figure out NPV again?
How,
Formula for NPV?
Do you want the formula that I'm using, or do you want the equals NPV? So it's just a sum. It's just a sum. So it sums the present value of the cash flow. So think about it. If you guys can see the color, okay. The idea is sum the blue values. IRR, use the orange values. Okay? And then payback also uses the orange values.
When you did pay special, what was you had pay special and what was it?
So you do, if you want to pay those, do pay special, values, and transpose. That is one of those quick little Excel things that you never know when you're going to use it, but it saves time and frustration.
Did you get this pay special like?
When you do a Control C, it'll highlight pay special. Also, you can do it. It's under Edit, under Pay Special. There's a couple places in Excel that. Okay, fantastic. Okay, let's do. Okay, let's do a third example. Okay, so we have a couple pieces of information that we're going to put together. We are going to try to determine what the amount of cash flow is. Okay, so that's our guiding question. So we have some information. Cash flow from operations is going to be $10,000. We have a sale of a machine. Which generates $1,000. And then we have additional working capital that we need. So back to our lemonade stand. So we're going to build our new lemonade stand. We think it's going to generate $10,000 in cash flow. We're going to sell the old lemon juicer for $1,000. And then in order to get our lemonade stand business up and running, we have to buy inventory, lemons, bottled water, sugar, all that stuff to make lemonade. So, one of the first things we always do with a project analysis is we try to get total cash flow. Okay? And in doing cash flow, we have to consider taxes. I hate to think about taxes, but taxes are a real cash expense that companies have. So we have to take them into consideration. So, when we calculate cash flow, we take after-tax cash flow from operations, which is item number 1. And that's actually after tax. So AT means after tax. Then we take our working capital requirement. Okay, so WC equals working capital. And then the third we take the after-tax gain on the sale, or loss if we've sold it at a loss. So we take those numbers, a couple of them we already have, one of them we need to work with. So the after-tax cash flow from operations is 10 grand. We have that right there. My working capital requirement is given $2,000.
Why is it a requirement down on the bottom, but just additional working capital? What does it mean by the phrase of working capital requirement?
So it means that we are going to add working capital to the business, and adding working capital is like adding cash.
Is it like additional paid capital from financial planning?
Do I like that comparison? No. It's like borrowing on your credit card. It's like taking a cash advance on your credit card. Slightly different. Okay? But it puts cash into the business. Yeah, Helene.
What's the -1?
It's not a, it's a, oh, hold on. I was trying to identify these. Oops. Okay. So they match down here. Okay. So the one thing that is not put into the tax lingo is the sale of the machine. So what we need to do is figure out if we have to pay tax on that machine. So we have to assess the gain loss on the machine. Okay? So we have this little kind of mini analysis that we have to do. So what we do is we calculate or determine what the sale price is. Well, I've told you that we sold it for $1,000. Okay? Then we would find is its book value at the time of sale. We would either determine that we would either calculate it or it would be given to us. Well, I'm going to give it to you. Its book value is 0. It's fully depreciated. So then this gives us the gain. It's called a gain. So if it was worth $100 at the time that we sold it, our gain would be $900. If it was worth $500 at the time we sold it, our gain would be $500. If it was worth $1,100 at the time we sold it, we'd actually have a loss. Okay, but it's worth 0. So why does that matter? It matters because gains are taxed. And if we assume this company's tax rate is 35%, we would take that gain, multiply it times 35%, and what that means is $350 is going to go to Uncle Sam, and the amount of cash that's actually going to go into our pocket is $650. So when I look at the actual cash flow, the amount, again, the amount of money that I'm going to put in my wallet, the after-tax gain on the sale is not $1,000, it's $650, because I'm going to have to pay tax on it. So when you guys are doing these problems, you want to isolate these types of sales of equipment or machinery or trucks or whatever and calculate this net gain. Okay, so this is sometimes kind of a sub-analysis that you have to do. Right, and then I can figure out my total cash flow by adding up items 1, 2, and 3. And there's no fancy formula here. So in the first year, you know, if we were working on this, we would maybe have total cash flow of $12,650. And it would come from 3 different things. Okay. Okay, cool. So this gives you guys a running start on some of these problems. I'm going to show you. Let me just save this real quick. So you guys are doing the baby steps on these problems. You got to do baby steps. Got to learn to, you know, crawl and then hobble and then walk and run. And eventually it explodes into an analysis that looks kind of like this. So what are you guys seeing? You guys are seeing a project that absorbed like 9 months of my life. So this company undertook a $50 million capital project to do like 3 or 4 things. 1 was to rebrand the company. 2 was to build out a website that better integrated their retail channel with their online e-commerce sales. Number 3, they wanted to put equipment in their stores so you could better experience their product, which was actually music, so you could listen to it. And then also to have a kiosk in their store where you could order something in the store that wasn't in their inventory. So over the course of 5 years, they were going to spend $55 million on this. So that little simple analysis that you guys just did is exactly what we did here. But it's obviously got a lot more detail in it. So you guys got a number, cash inflows. Okay, well, what we had to do was calculate that. And so we went into their business. We had 3 different sources of incremental revenue. And then what we did is, where'd it go? We did some modeling of little things like how many people come into the store, how many like stores with a kiosk would now exist, and what would that mean in terms of their traffic, and then how many people would go in and buy something And then of those people that buy something, how much are they going to buy, how many units, how much are they going to spend, et cetera, et cetera. And it all builds up to, if revenue last year was $100, this year it would be $105, right? So lots of detailed analysis to figure out all that stuff. And then we would go through and figure out, well, how much is it going to cost them? So we had, lots and lots and lots and lots of details, right? Doesn't matter what the numbers are, but lots of details. And this is just the ongoing operating expense. And then we had the kind of one-time capital expenses. So if you look at what I was telling you, that most of the expenses happen in year 0, this company was rolling out this project, and those expenses would happen kind of over the course of 3 years. So rather than having them all in year 0, they happened predominantly in the first 3 years, and then they would have some additional investments ongoing. All right. And then you have to depreciate all that stuff, so you have these really complicated spreadsheets. Okay. And then to make it really fun, every time we made a change to the assumption, the CEO wanted to know the impact of the change. So how did that one single assumption change impact revenue, net income, cash flow, NPV, return on investment? Every single time we made, 21 major changes in a 3-month period. We would update the assumptions and then present to him, hey, here's how the financial model. Because when we started this project, their net present value, if you guys can see that number, the NPV on this project was going to be $129 million. This is a $7 billion company. By the time we made all those changes, it was only going to be $119 million. So the CEO freaked out a little bit because he felt like we had lost $9 million worth of value, and he wanted to know exactly how all those changes had impacted $9 million of value. So the stuff that you guys are working on, again, it's not artificial. And by the way, when I built this, there were probably 30 people in this company who were contributing. So people in sales, people in marketing, the store managers, the HR team that trained people, the people in the supply chain organization. This company, because they sold music, they had a whole, I don't know what you would call them. They would have rock stars come to their headquarters and do concerts and things like that. So they had the people that sort of managed the trends in music, and they were overlaying some of that to make sure that some of the things that were actually going on in the industry were being considered, right? So you guys may never be the actual spreadsheet builder, but you could be a contributor to the process because literally it touched every single functional area of the business. All right? So it's okay to start with the small steps. We won't have something like this on the exam, just FYI. But I think it's nice to see kind of what the extent. I mean, this is a pretty complicated financial model, probably one of the more complicated ones that I ever built. Okay, spectacular. All right, so again, on Friday, you're going to have a short quiz, maybe 4 or 5 questions. I'll probably open it early in the morning. It'll be due end of class time. And then I will have the instructions for your film assignments. If you guys don't see a film on the list and you would like to watch something different, please email me before Monday. Depends how that game's going tonight.